Hi students, today we're going to do section 4 of chapter 10. Nuclear forces. A strong nuclear force is a force that bonds the protons and the neutrons together inside the nucleus. This is greater than the repulsion force on protons. So protons, remember all protons are positively charged. Two positives don't want to be next to each other, that they repel each other. However, the strong nuclear force overcomes that repulsion of the protons. In unstable nuclei, however, that happens when the strong nuclear force is not greater than the repulsion force. So the repulsion force, how protons want to repel each other, is stronger than the strong nuclear force. All nuclei with 83 protons or more are radioactive. No matter what isotope it is, they're all radioactive. They want to, there's just so many protons in there that the strong nuclear force can't overcome that repulsion, and so that's why they want to decay. Fission. Fission is the splitting of nucleus into two smaller parts. So you have a large nucleus and it splits into two smaller parts. This creates a lot of energy with a small amount of mass. If we aren't actually going to do any math with this, so this is how mass is converted into energy, and this is Einstein's equation. E equals mc squared. E is your energy, m is the mass, and c is the speed of light. If the speed of light is 3 times 10 to the 8th meters per second, so that means it's 300 million meters per second. And then you square it. So you're taking 300 million, squaring it, so timesing it by itself, which is why you only need a little tiny bit of mass to create a ton of energy. So that's why elements, nucleuses, that have very, very tiny mass can create a ton of energy. More about fission. A chain reaction. Chain reactions occur when neutrons are released during the splitting of an initial nucleus, triggers a series of nuclear fissions. So when you split the nuclei, some neutrons will come out, and then those neutrons will hit more nuclei, which will cause those nuclei to split, and then it will continue on, and it's called a chain reaction. There are two different types of chain reactions that you can have. You can have an uncontrolled chain reaction, which is nuclear weapons, or you can have a controlled chain reaction that is found in power plants. So nuclear power plants use fission. Fusion, on the other hand, is the opposite. Fission splits nuclei. Nuclei is you take two small atoms and they combine to form a larger nucleus. So they create a big nucleus. Fusion is what powers the sun and other stars. So it also creates a lot of energy because the sun has a ton of energy. We would love to be able to use fusion as an energy source. So it could be used as efficient and clean source of energy in the future if science can overcome two problems. So there's two problems before we can actually use it as energy. First, it needs a very, very high temperature in order for fusion to work, and so right now that's inconceivable. As well as we need plasma. Plasma is actually the fourth state of matter. You guys are used to liquid, solid, and gases. There's 3 states of matter. Plasma is also the fourth state of matter, and it's in which atoms have been stripped of their electrons. You need to have plasma in order for that to occur as well. That is it for today's notes.